Alright lads and lasses, welcome along, Tuppence Tuesday here once again, Do you know, honestly, right, things are going great. You can see me face, this is me, it's what I do. Gonna go through one of the topics that's a real big one. Now, the main dataset videos we're doing, dataset 6, we're gonna cover a lot of this as we're going through it, but I wanna get this in there and start your minds thinking about it, yeah? So, X to the Z, yeah, or like totals, right? What do I want to talk about today? What's the point of the day, yeah? Right, tabular models. Power BI is built on tabular models, right? And then it's got DAX. Both of them are all about columns and doing stuff in columns. That's the main benefit of it. It's all about columns. That's the secret sauce, yeah? Do it in a column. What's the column? How do we make the column do something for us? So how do we understand that? What does that mean in terms of me data, right? And why are we talking about this now on a fine Tuesday? Wait, because X functions are in. Now, as we go through and talk about DAX and stuff like that, we're going to really quickly get into something that brings you to context. And context is everything in Power BI, and it's really key for you to understand it. Now, one of the things that breaks all the rules in Power BI is the X functions. So honestly, if you're new to Power BI, don't worry if this video makes no sense to you, right? What I want you to do, watch dataset 6, watch the videos on that, right? Or if if you're still done, right, because I'm still shooting them, aren't I, watch dataset 6, and then let's come back, revisit this video again, all right? So I'll tell you what, should I pause it now? Right, right, let's come back now. Great, we're all back, everyone's happy. We understand what went on in dataset 6 now, don't we? Oh, that was alright, that was good, that stuff. Now, what's these X functions all about, I hear you say? So, every now and again, you've got a need to do something more with a column, right, or with a table of data, right? A real classic is exchange rates. Now, exchange rates are a really great use case for an X function, right? And they're also a really good example of when X functions are overused. So I'll take you through what I would mean by that. So an exchange rate is where, well, I've got a value for a sale or for something like that, yeah? And then I need to do something with that, with an exchange rate. So, it's multiplied by 1 point or 0 point something so that you get the adjusted value for whatever your new currency is. A sum X is really great because it will do that for you. Now, there are lots of reasons why you would want to do that, and especially if you've got like a column where there's lots, or a table, sorry, with lots of different currency values in it. So you might have euros and dollars and even some pounds thrown in there. And then you want to be able to work out what's the exchange rate, what's the total amount in GBP. So your GBPs will be times 1, and you've got some which will be 0.8 and some which will be 1 point something, 1.12, something along those lines, right? Sum X is the only real way you can do that quickly and efficiently, okay? Best way to do it, right? Especially if you want to maybe be able to be flexible and say, well, I want to look at it in GBP or in something else, right? Sum X, that's all you can do, right? Where it's been overused is if you get to the point of saying, well, we know we're going to need to do an exchange rate calculation, we might as well just do it as we're bringing it through the M stage. So as we're doing the data model build, we do the exchange rate calculation and then have a GBP sales value, a euro sales value, and a dollars sales value actually there in the table, right? And there's all sorts of reasons why one is better than the other. There's all sorts of times when this is the right way to do it versus that. But the key thing is it's possible to do both. So you need to think through which one you're going to use and why, right? But we'll get onto it, we'll have a look, and it'll make more sense when you have a look. Crack into a demo, and then we'll see what's going on. Alright, so way back when I built this dataset 3, yeah? Newcastle City Council's library loans. So how many books have been loaned out across Newcastle every year, right? Now, it's dead easy, this one. This is a nice, simple book, or simple dataset, yeah? So we've got kind of books, we've got a title for the book, we've got an author, and we've got a year in the main data set, yeah? So we know what year we're talking about. So this is 2016, Alan Alberg, Mrs. Plug the Plumber. Now, I remember that when I was growing up. That was a brilliant book. I loved that when I was dead young, when I was a young'un, right? Champions, great, still out there, still getting read, eh? But the main thing is that you can actually go through and start to see what's happening. So one of the big things that you might want in that, and I'll just shuffle this out to the side a little bit, just make it easier, all right? So we might say, well, how many times are each book getting loaned out? So we can say, oh, I want to know the number of times it's been loaned out. Yeah, so what's that going to be? So like the loans per book or per copy, yeah? So we've got 39 books and they've been lent out 69 times, yeah? So we could just, back of a fag packet type calculation that, couldn't we? Yeah, so I could say, wait, I want to understand the loans per copy. So I want to take the sum of the loans and the sum of the number of copies, right, and divide the two together. Yeah, that's, we can see that, how that works. That's not a bad measure, that makes sense to me, yeah? I could get behind that, no bother, right? So let's whack that in there. Job's a good one, right? And that works, that kind of makes sense. I can kind of get behind that, right? So let's look at this one here though. So, hang on. So we've got 11 and it was rented out 110 times. That's 10 times per book. We've got 14, 110 times again. That's 7.86. So we can kind of, what happens if let's take away the years from that. So we've got then Jeffrey Arthur coming the hour. Oh, hang on. Jeffrey Archer cometh the hour. That doesn't look right now. Yeah, 25 divided by, well, it's right, but is it right for the time? Where's the context of it? So because it's a sum, which is what you've got, you're doing a sum, you're doing it based at this level. So 220 divided by 25 is 8.8. That's what it is. If you want to figure out, well, actually, what should it be? I was thinking through what's the right way to do, what's the best way? Chances are the best way to do this is like something like an average x, right? So like an x function, but the average. So what's the average value of this to this? Now, there's going to be times when it's not the right thing, especially if you've got big aggregations, but I think it's going to get you a better result than what you would get with the other. So what does an average x look like, given that this is what sum? Now, you can see here, we've got to do columnar, yeah? Sum is a column, isn't it? So columnar, we've done things with a column. Average x is a little bit different. So what average x here, we're saying, and most x functions, the difference being rank x, which is slightly different, but average x, sum x, min x, max x, all of them, it's basically the same. Tell it what table to do it with. So what table, and we're going to go down row by row in. Yeah, and the row by row is to do with where we've got to with we're filtering. So row by row, based on the table of data that we've got at this point. And then for each row, do something different. Or do the same thing, do this. So in this case, in each row, we're dividing the number of loans, and you see there's no aggregation on here because I'm in a row. What's to aggregate? I've got one value. You've got one value. What you're playing at, man. It's dead easy, right? So we've got this number of loans, number of copies. Yeah. So we can bring that into a calculation, into a table, and we can see what does that look like. Now, if we remember, we had that Jeffrey Archer one come with the hour. Now, hang on. 8.93, 8.8. So there are differences that start to creep in here. Now, the average x is probably closer to the truth. I think, remember, this is going to be the average number of loans per book of 7.2, which is probably a better number to have than this number, which is effectively this divided by that. This is, for each of the rows of data that you've got, what's the answer that you end up with, right? And this is going properly through the rows of data. We can see from the way it's built. This is ignoring the aggregation here, and we're going straight back to the table, and we're saying this piece of data, on the inside here, this piece of data is part of it. So do. And then Whereas the other one's just saying, well, here's the aggregation. This is the total number of loans. This is the total number of books we've got. Boosh, right? Job's a good one. So it's not, they're doing it slightly differently. And this is where you need to get a bit, start to understand it now. So the X functions will produce a table, and then from that table, they will iterate down through it. Now, because they're iterating row by row and carrying out a calculation step on it, and to be honest with you, because it's going row by row, if you've got a table, and remember you're telling it the table here, yeah, so in this case we're doing library, if you've got a table and it's got 20 million rows, an X function is going to be like the last thing you want to do, right? Because it will go really slowly. You go ba-bang, ba-bang, ba-bang. Might be doing each row really quickly, but when you've got 20 million rows to do, it ain't quick, right? And remember, the whole point of Power BI and tabular models is to be columnar. So it's all built to make things work as a column. So if you want to sum a column that's 20 million rows, it's pretty quick because it just goes, here's my column. I've filtered it down. These are the values that we need. Done, right? Dead quick, dead easy. Whereas the average X, the sum X, the min X, the max X, they're going through and saying, all right, I've got 20 million rows. Right, for row 1, 132 divided by 75. Right, for row 2, 72 divided by 17. Right, for row 3, right, and then you've got to add that result together and keep adding them all together. And then remember, at the end, we're going to have to remember how many rows we went through and then divide it by that. Yeah, right, I know what I'm doing. Yeah, it's not quick, right? It's not to say it's not intelligent, it's not smart, it's not brilliant, but it ain't quick. Careful of those when you're doing lots of things, right? So your filters, you've got to be careful of the filter. If you're going to use filter, that's a really bad one because that's going to go row by row and evaluate. Do you meet my criteria? Average X, sum X, all those, right? We'll cover them more in future videos, right? But I want this one to be one that you watch and you go, oh, I don't understand. I didn't get it. He's talking rubbish. I don't know why I'm bothering with this channel. He doesn't make me life easy. It's just all about rubbish, right? But I promise, if we keep niggling at you and having these little bits of, hey, have you heard? Have you thought about? Some point it just starts going like, oh, I get what he's meaning now. That makes sense, right? He's not a complete bomb pot anymore. Can I get it? So have a gun, right? Have a look at this data set or do something similar, yeah? Tell you what, I'll try and figure out how we can start sharing some data sets in this. That's my next challenge today, right? How best can we share data sets with this lot? Okay. This one, I'll put the link to where I downloaded it from in terms of the raw data. In terms of the steps, it's a load of CSV files, just pull them all in. You just needed one though, so you could do it with just one, right? And you can try it. But I'll put the link on where I got these data sets from, right? You can have a look, open data sources, but think through when you're doing your calculations, when you're building your DAX statements, what are you doing with your DAX? Is it a columnar-based piece, or is it something that you're going row by row and going to force and embed some real? See you later. Cheers. Ta-da.